Welcome back. Today we're going to look at multi-file programs, the StringStream class, and some common errors with functions. So, up till now we've made all of our functions in driver.cs, the program with main in it. But what is better is to put our functions in a library file. And this is what we mean by multi-file programming. So driver.cpp will just contain main. Functions.h and functions.cpp will actually, those two files together will form a library with our functions in it. And we're going to put the function prototypes in functions.h and the function bodies in functions.cpp. So the way your programs will look is like this from here on out. You'll have your driver.cpp, which will have main in it. And main will typically call a bunch of functions to make the program work. And you'll notice that we have this include statement that says include functions.h. So we're going to add an include statement just like we did for IOStream. But instead of IOStream, we're including functions.h, and notice that functions.h is in quotes. And then notice that we have no function prototypes here now, and we have no function definitions in driver.cpp. Instead, we're going to put all of our function prototypes in functions.h. And you'll also notice that we have this if-and-def and define directive at the top with underscore capital functions underscore h. Other than that, this looks a lot like what you've been doing so far. We have includes that we may need because we're referencing IOStream or string, and then we have using namespace standards as well. And then our function prototypes, but you'll notice you have if-and-def underscore functions underscore h, and that if-and-def is terminated with another preprocessor directive, which is endif. And then inside of here, you have define underscore h. So what is that about? Well, we don't want to have our functions declared more than once. And in order to prevent our functions from being declared more than once, we use this thing called an include guard, which is the functions, the if and def underscore functions h and define underscore functions underscore h and then endif. And between these two parts of the include guard, we'll put all of our the rest of our header file between those. And what this will do is when it first comes through here, the compiler will say, hey, if underscore functions underscore h identifier has not been defined yet, then go ahead and do the stuff between the if-and-def and the endif. And that will include, one, defining functions underscore h so that when it comes back around, this if will fail and it won't execute this a second time. But then in addition, all of our code here that we want to use to define our functions. So this include guard is vital that you include it in all of your .h files, and it will keep from defining the function twice. Note that you may see when you start up a .h file, you may see a directive that says pragma once. Make sure if you use this type of include guard, you delete the pragma once. And then here we have our functions in the functions.cpp. So the function definitions go in functions.cpp. The prototypes go in functions.h, and the function definitions go in functions.cpp. And you can see here it has the function bodies. So it includes the blocks of code which explain have the code for how the functions execute. Notice that the functions.cpp also, just like driver.cpp, has an include statement for functions.h. You do not include functions.cpp in your driver. The only thing that gets included and that's in driver.cpp and functions.cpp is functions.h. So this code here. So let's see what that looks like. So here we have a program that uses multi-file programming. We can see we have a functions.h, a driver.cpp, and a functions.cpp. So let's look at the functions.h and functions.cpp side by side. And I'll often dock them this way. You can dock your windows by grabbing a window, moving it around, and you can see this little widget in the middle. It will give me options for docking a window. So I'm going to dock it to the right so that we have both of them side by side. And we can see the functions.h has this include guard. So that's the include guard. And the convention is that for the identifier, you use an underscore, then the name of your file in all in caps with an underscore instead of a dot. So then the reason we follow this convention is that way no two files in your project will have the same include guard identifier, and so that'll prevent you from having accidentally defining the same identifier for two different function files. And then over on the left, we have functions.cpp, and you can see this is just the function definitions. One recommendation I make is as you're writing your functions, write the functions in functions.cpp first, and then copy and paste the top part of the function over to the function prototype. Don't forget to add the semicolon, and that will ensure that you never get these out of sync. If these are different, you'll get some errors. So make sure they're always in sync by copying and pasting from the functions.cpp to functions.h, and do all your changes in functions.cpp. And then if we look at driver, we see that driver just calls the functions that are defined in functions.h. So I often set up this way where I write my functions, I move the prototype over, then I go to driver, and then I make my function call. And so this kind of works pretty well. So the big points for using multi-file programs: create 2 additional files in your program. One is a .cpp file and one's .h. Name it, give it a name that makes sense. In this case, we're just using this for generic functions, so we're calling it functions. And then in your .h, make sure you have your include guard. And then in your functions.cpp and your driver.cpp, you have an include functions.h. And note, you can have multiple function.h and function.cpp files. And you can organize your libraries to be logical. It's a much more complex program, would have many more library files than just necessarily one. But in this course, you'll have at least the one. So what do we use if and def and define for in a multi-file program? Do we use it to define a name for the program? To prevent a header file from being compiled multiple times? To ensure the header file is compiled each and every time it is referenced in an included library? Or none of the above? So pause this video, think about your answer, and then hit continue. So the answer is to prevent the header file from being compiled multiple times. We only want the functions in the header file to be declared one time. Otherwise, you'll get a redefinition error. So that's why we have the include guard. So at this point, recommend that you complete the multi-file demo. The string stream class is a useful class for building strings. And it's referred to as a stream object because it works very much like other stream objects, like the keyboard and the screen. So, in fact, you know very much, you know a lot of what you need to know in order to use a string stream class because you know how to use cout. So, when you need to write your program data into a string in a formatted manner, the stream class will make it easy because you'll be able to use the stream operator, this less than sign, and use the same formatting that you use for cout. Then once you stream your data to the string stream object, you can use the string stream's str function to turn all of that data into a string. So here's an example of how the string stream class works. We declare a string stream object here, and you will have to include the stream library. We then, in this case, we're creating a bunch of variables, and you can see here we're writing those variables to the string stream object just like cout. But instead of cout, notice we're referencing, instead of cout here, it's the string stream object that we have created. And you can see that you can use iOS fixed, just like you do with a cout. You can set precision. You can do the same things to format your output as you would with cout, except that instead of going to cout, you're streaming to your string stream object. When you're finished writing what you want to the string stream object, what you can then do is use the str function of the string stream object to take whatever was streamed into the string stream object and turn it into a string. And then if you output it, you'll see what's in the string. You can note that once you output the string like this, you can still add more things to the string stream and then call the string object again and it will display it. But it will have everything that was in there before. So we'll just keep adding things to that string stream. And so if we were to execute that code, we would see that the first time we ran it, it would look like this. And then the second time we added some more to it, and now it looks like this whole section down here. So let's write code to instantiate a string stream variable called bank balance and initialize it to bank balance. Concatenate to a float called float balance and format the results so that it shows 2 decimal places of precision after the decimal point. So pause, write down what you think the answer is, and then hit continue. So let's see how we do this. Well, we're going to be using string stream, so we're going to have to include the stream library. And then we'll declare our string stream object, and they wanted us to call it bank balance. And the temptation would be to initialize its value to say something like this. And they want us to have they wanted to have a float variable called float balance as well. And I'm just going to say, just initialize it to value of 10. And it might be tempting to do this, but realize bank balance is a stream object. And so you can see that you can't even put a string inside of bank balance with the assignment operator. We don't use the assignment operator with stream objects. We use the stream operator. And it's just like writing to cout. So we would do this like this. Just like we're writing to cout. In fact, if we ran this with cout, you would you would see that it would output there, but we're not wanting to go to the screen. We want it to go to the string stream object. So that's what goes in here. Now, the other thing they want us to do is format the result so it shows 2 decimal points of precision. So the way we can do that is the same way we would use for cout, except that we will use bank balance. So I'm going to set the precision to 2 decimal points, and I want that after the decimal points. So I'm going to set f iOS fixed. And then just to see what we get, let's start off actually showing you that this is the same thing as cout. I'm going to just replace these temporarily with cout. And maybe we'll throw in an end line just so that it's at the end and see what that looks like. In fact, this is a way you can kind of prep your string stream before you use it, as you can build it for cout, and once you get this the way you like it, then you can replace your cout with your string stream object. And then just to see what we get, I'm going to create a string and just use the string stream's str function, because often you're going to be using this in a function and returning it as a string, or you're going to want to store what's in this string stream object as a string at some point. So we're going to use str to make a string. It'll take anything that we streamed into this bank balance string stream, and it'll store it in the result. And then just so we can see what that looks like, I'm going to cout result. And we can see, yeah, this does the same thing, except that we put everything into bank balance, then we turned it into a string. Now, this is often used as a function. So you'll often have it like this, maybe a function that returns a string called and we'll pass in a float, maybe something like this, and our code will look like this. So we have a string stream object being created inside this function, and then we fill it with whatever we want, whatever report we want. Then at the end, we get a string, put it in result, and then return that result. We can then, we no longer need this. And we'll just call our function now here and pass in so now what happens is we have some balance, we pass it into this get summary, it gets a result, and then we can output that result. Does this work the same? We're missing one thing, of course. We have to put our prototype before we use the function call at the beginning. And we can see, yeah, that works the same, and now we have it as a function. Can we simplify this a little bit more? Absolutely. We don't really need to put this into a string and then just return it. We can just do our return here and just return the string stream, but call the str function so that we're returning the string from the string stream and not the string stream itself. And then what I could also do is make this into a multi-file program. So I will add a new item. I'm going to add a .h, functions.h. When you make a functions.h, you'll often see pragma once. You kind of don't. You can use that. That works the same thing as our normal include guard, but for this class, we're going to use the older style of include guard, which is if and def. And then traditionally it's underscore functions underscore h. And then we will define underscore functions underscore h. And then this is where we're going to bring over the function prototype. We can see it needs the string library, so we're going to include string. Actually, it probably doesn't even need that. It just needs a using namespace standard. Maybe it does need there we go. And then I'll need to add an include. Watch your IntelliSense, because sometimes it already knows. It knows it needs a functions.h. And then we'll need another CPP file, but this one's just going to be called functions.cpp. And we're just going to take this function definition out of driver.cpp. We're going to place it in functions.cpp. It's going to need the using directive and probably some includes. So all those red squiggles went away because now we had the includes. And then typically, you want to have you need to have a comment header on all code you modify. And we also include functions.h in the functions.cpp. So both the driver and functions.cpp will include functions.h. And so now we have this function in a library. And let's see if it still works. It does. So we've successfully made a library function with our first, with this get baked ballots. And that's how you make a multi-file program, but that's also how you use the string stream library to make a nice little function that will stream together a nicely formatted output. So let's look at some common errors with functions. So one common error is you get a function does not take underscore parameters. And in this case, we have a write function where we're passing in two parameters. And there's the function. But you notice that there's a mismatch between the function prototype and the actual function definition. This is why I recommend copying and pasting the the header line of your function to the function prototype and never really editing the function prototype directly. And that will cause this parameter error. Another error you might get is link error unresolved external. And let's see, we have a function prototype here, and then notice that again we have a mismatch between the function prototype and the header line of the function and its function definition. So when that happens, you're going to get a link error because it's not going to find this function definition. It doesn't match the prototype list. So like I said, if you copy and paste the header line to the function prototype and never edit the function prototype directly, you'll avoid that error. Another one is missing function header. And so here we have our function prototype. And then in the function definition, this is one that almost everyone does. You're getting used to putting semicolons at the end of every statement, and you accidentally put one in your function definition right after your header line. When you do that, it disconnects this block of code from this function definition. And so the solution is to remove the semicolon, but just realize that's a common error as well. So let's review some elements of functions. Functions require two sets of statements, a prototype and a function definition. The function prototype needs to go before you call a function, and the function definition can go afterwards as long as you have a function prototype. And the header line of the function definition and the function prototype are basically identical. You can copy and paste them, and that's what I recommend you do. And then the call statement is the location where the function is called. That's often in main, but you realize that functions can call other functions, so it can also be in another function as well. Remember, the call requires only the variable names or the values. You don't get in the habit of copying your function prototype into main in order to make a function call, because then you have all the type names, and that will mess up your function call. Just write it. It's easier. Functions can be overloaded, meaning that two functions can have the same name as long as their parameter lists are different. And you can also use the assignment operator when you're declaring a parameter to assign default values. You can declare global variables outside of all your functions, and all the functions can access them, but we really don't recommend you do that. So avoid that as much as possible. Go ahead and declare your parameters and pass your values through. It'll make your code easier to read and easier to maintain, as well as save memory. And so we want you to use local variables and pass things that the functions need through their parameters. We also showed static variables, which are local variables that retain their value even after you exit a function. So that's what we reviewed today. Thank you very much.